Hello everyone. Today we are going to be solving with log properties. We're going to take what we did in our previous lesson with the log properties, both expanding and condensing, and we are going to use those properties to solve equations. This lesson, as always, is brought to you by Conalenzo Inc. We are here to help you with anything that you need for math, and we hope that you are learning all about logs and enjoying the time. Our goals for today are to be able to solve log properties, or solve equations, with log properties, and also to determine whether we need to solve by rewriting or by canceling logs. So we're going to have a couple of different methods here, and we need to know which one is the best to use when. We're going to talk about analyzing an equation to see and understand what we're given, and then how to appropriately solve that. Our log properties, remember, tell us that when we are adding, we multiply, or when we're multiplying, we add. Subtraction and division go together, and then powers and or exponents and multipliers go together. We need to condense. Remember, we talked about canceling out logs with the same base. That only works if you have one of each type of log. So in this equation that's given here, I cannot go through and cancel out all the logs. I could cancel one for one. Whoops. But I cannot cancel out all of them. So what I want to do here is to condense on the left side so that I get it down to one log. So I'm going to start with my rule that tells me that a multiplier becomes an exponent of what's behind. And I'm going to rewrite this as log 5 of x to the third minus log 5 of 4 is equal to log 5 of 16. I've condensed a little bit, not completely, but I have simplified. Now I'm going to remember that my log properties tell me that division means subtraction, means that I divide the parts. So I'm going to condense this even further into x cubed divided by 4, so that now on the left side, I only have one log. Now I can cancel. Because I have a log 5 on each side of the equation, those can be canceled out, and I can solve what is left, which is x cubed divided by 4 equals 16. My first step is going to be multiplying both sides by 4, and 16 times 4 is 64. Then, if you think back a couple of lessons, we talked about exponents and how to solve exponential equations. We want to know what number to the third power is equal to 64. There's a couple ways we can do this. We can go to our exponent chart and we can look through and see what number to the third power is equal to 64. We would then see that that would be 4. We could also take the exponent and flip it to the other side and use our calculator to evaluate 64 to the 1/3 power. We would also get 4 for that. So there's a couple different ways that we can solve once we get this exponent here. Your choice, whether you want to use your calculator or you want to use that exponent values chart to get that final answer. So we went through and we condensed in order to get one log on each side so that then they could cancel. Let's try another problem here. We're going to look at this left side here, and again, we want to try to condense. So I know that my log properties tell me adding means that I multiply the parts. So I'm going to condense this down and make it log base 8 of x times 12. I could also write that as 12x, okay? Doesn't matter. That's equal to 2. Now, I don't have a log on the other side that I can cancel with. So this tells me that I'm going to need to solve by rewriting in exponential form. My base is 8, my exponent is 2, and that's equal to my answer, which is 12x. Now I have an equation that I know how to solve. I know that 8 to the second is 64, and then I can divide 64 by 12, and I will get an answer for x, which is 5.33333, etc. We always want to be exact with this because if I plug 5.3 back into the equation, I'm not going to get an exact answer. So I want to leave this in fraction form. Remember that we have that button on our calculator. If you hit second and you hit the ABC button, it will transform this into, second and the PRB button, it will transform this into a fraction, which we can change to an improper fraction, of 16 over 3. Or you can just remember that it's 64 over 12 and then reduce dividing both of them by 4. Either one is a valid option. So we get an answer here of x equals 16 over 3. Now we've solved two different ways. Both of those have started with using our log properties to condense. So looking at this next one, I want to condense on the left side. I see an addition sign, which tells me I want to multiply my two parts, which is x and x minus 6. Now, first thing I want to ask myself is, do I have a log on each side that I can cancel? The answer here is no, which means that canceling logs is not an option. My second option then is, do I need to rewrite this in exponential form? I can. My base is 4, my exponent is 2, and that's equal to my answer, which is x times x minus 6. Now I'm going to solve all of this out. So I'm going to start by 4 to the second power of 16. And I'm going to distribute the x times x minus 6, which is x squared minus 6x. The reason I did that is I want to make this equal to 0 so that I can hopefully either factor or maybe complete the square to solve. This one is factorable because the factors of 16 but subtract to be 6 are negative 8 and positive 2, meaning I have two answers for my problem here. Okay, I have 8 and I have negative 2. I do want to check these and just make sure that these are correct. So what I'm going to do is I'm going to go back to my exponential function, and I'm just going to check both 8 and negative 2 to make sure that they work, okay? So 8 times 8 minus 6 is 2 is 16. 4 squared is equal to 16. Negative 2 times negative 8 is also positive 16, which 4 to the second is positive 16. I really just want to check and make sure that I don't get any negative numbers, because remember, anything to an exponent does not result in a negative answer. Let's try one more here. I'm looking at this one. I see that I have one log on each side, but because of this 5 here, I cannot just cancel them out. So first I need to use my log properties to rewrite this, moving that 5 to become the exponent of my x that's behind. Now I can cancel the log 3's that appear on each side, and I can solve what's left. Again, there's a couple ways I can solve x to the 5th equals 32. I can go to my exponent chart and I can find the value that 2 to the 5th power equals 32, or I can flip my exponent to the other side and take 32 to the 1/5 power. Either way, I get that x is equal to 2. I have solved this. I am good to go using my log properties and then canceling my logs in order to solve. Now, this one is a little complicated. We've got a couple of things going on here. We've got this 4 that we need to move back as an exponent. We also have this minus, which tells me I'm going to be dividing my parts. I'm going to start with log base 2, and I'm going to take x to the 4th divided by 5. So I kind of did two steps in one there. I moved the 4 back to be the exponent of x, and I divided by 5. And that's going to be equal to log base 2 of 125. Now I have a log on each side, which means that I can cancel. And I'm going to solve what's left. So x to the 4th divided by 5 is equal to 125. My first step is to multiply by 5. And then my next step is to either use my exponent chart to figure out what number to the 4th power is 625, or to flip the exponent and evaluate 625 to the 1/4. Either way, I get 5 as my answer. So x equals 5 here. I hope this is making some sense for you. I hope that you feel like you are able to use the appropriate log property based on whether you're adding or subtracting, or if you have that number out front, and be able to condense the logs. I hope that you are understanding whether to cancel logs or to rewrite an exponential form in order to solve completely. Let us know if you have any questions or if you need any help. We are more than happy to work with you and help you solve some of these log equations. Take care.